Hello and good evening to everyone present here. So this is Harish J. So now we are going to see something about laser interferometer. What is a laser interferometer? Interferometers are investigative tools used in many fields of science and engineering. They are called interferometers because they work by merging two or more sources of light to create an interference pattern. So here, interference pattern refers to both either constructive or destructive, which can be measured and analyzed. They are often used to make very small measurements that are not achievable. So here, not achievable refers to we cannot use scales, screw gauges, vernier calipers to measure that small measurements. Interferometers were actually invented in the late 19th century by Albert Michelson. So types of interferometers. There are many types of interferometers, but only 5 seems to be very famous. So we'll see the 5 now. So the first one is Michelson interferometer, which was created in the late 19th century. You can see the respective image on the screen. So next is the Fabry-Perot interferometer and Fizeau interferometer, and their respective images are on the right side of the screen. So next is the Mach-Zehnder interferometer and Taiwan Green interferometer. So in case of Taiwan Green interferometer, at the image there's something written where the center of curvature of the spherical mirror coincides with the focus of the lens under the test. So that's written here. So guys, I don't want to get into the types of interferometers because it takes even more lot of time to explain each and every kind of interferometer, as each and everything is different from one another. So next we'll see how they work. That is how laser interferometer works. So interferometry involves taking a beam of light. Here the beam of light refers to the laser, and this laser is transmitted through the beam splitter. So that is splitting of laser into two equal halves. So this beam splitter is nothing but a mirror which is coated with silver lining. So this acts as half mirror, that is, it is half transparent and half acting as a mirror. So as you can see in the image here, so the laser comes through the beam splitter. So this beam splitter, as I told you, it is a half mirror. So it can pass through the beam splitter and it can act as a mirror and go towards the mirror which is present in the top. So after that they merge, they again reflect back and merge together, and they hit on the screen, therefore showing this interference pattern, as you can see here. Here for reference we are considering the color beams. Actually there will not be any difference in the colors of the beam unless and otherwise you change the color of the laser. So now if we take a green beam to be the reference beam, we subject the blue beam to some sort of the change we wanted to measure. The interferometer combines the two beams, and the interference fringes that appear on the screen are a visual representation of the difference between them. So that is written here. So that's what the green thing is acting as a reference, where the other thing is used to measure, and that interference pattern, fringe pattern, is seen on the screen. That is here. So the continued thing. So when the two light beams meet up at the screen, they overlap and interfere, and the phase difference between them creates a pattern of light and dark areas. So as I told you guys, that is the constructive or the destructive. So we'll just see now. The light areas are places where two beams are added together constructively and become brighter, and the dark areas are the places where the beams are subtracted from each other destructively. So that is the constructive and the destructive interference. The exact pattern of interference depends on the different way of the extra distance that one of the beams has traveled. So distance between the mirror and the laser, that's what is mentioned here. By inspecting the measuring of the fringes, you can calculate the great accuracy and gives you an exact measurement of whatever you're trying to find out. So that's it. So instead of interference fringes falling on a simple screen, often they're directed into a camera to produce a permanent image called interferogram. in another arrangement, the interferogram is made by a detector like CCD image sensor that converts a pattern of fluctuating optical interference fringes into an electrical signal that can be very easily analyzed with a computer. Technology is improved. So now we'll just see the limitations. There are quite few, so it is very advantageous to use something called laser interferometer wherever you are not able to use screw gauges, vernier calipers, and scales. So the limitations of optical instruments, optical aberrations. So optical aberrations is nothing but extra signal which occurs during the laser transmission and interference pattern on the screen, and denoising and the effect of noise on phase unwrapping. So basically these are the two major limitations of laser interferometer. Other than this, you see it is a very advantageous tool used to measure very small distances which are not achievable. So next we'll see a marketing video. Hello guys, so there is a new project launched in the market, namely Well-Fi Laser Interferometer, as you can see down in the advertisement. So basically this particular laser interferometer is actually cost effective, less optical aberrations, so one of the limitations is actually avoided here, and available in different colors and models, as you can see. And these guys are giving a 10-year warranty, so now you can understand how good the product is. And as you can see, there are different models also available, like basically starting from normal, HD, HDX and infrared, on whatever choices you want. And of course accessories are also available, so come and buy this as soon as possible so that you get a discount too. So whatever is not achieved can be achieved with the help of laser interferometer. Thanks.